Okay, so for this experiment, what we're going to be doing is using a hairdryer and ping pong balls to just represent kind of like the pressure of air in this scenario. So what's going to be happening, and it's not super obvious because this hairdryer is not very powerful, but what's going to be happening is there's going to be hot air and more powerful air rushing up from the hairdryer. And then gravity's going to stop the ball. So I'm going to put the ball over the hairdryer, and hopefully the ball will float right above where the air is pushing out. And it won't go too high. It won't blow like, whoo, like all the way off because gravity is going to keep it down as well. But the reason that this will work is because the pressure in the air around the hairdryer is actually going to be higher than the pressure where the hairdryer is blowing air. And because of that low pressure, the ping pong balls are going to be attracted to that and try to stay above that air rather than fall out. So we're going to just show that happening right now. All right, so here we go. Okay, so as you could see during that experience, the ping pong ball would stay above the nozzle where the air was coming out for quite a while before it fell off. The air's not that powerful, so it's not going to go super high, but it did go and it floated there for a while. And one thing we were supposed to try and do was put 2 ping pong balls on there at a time, and I'm going to represent that in a second, but it's not going to work. I've already tried it. The 2 ping pong balls, there's just not enough air coming out of the hairdryer, but I'm going to give it a try. See what happens, see if we can notice anything. So here we go with that. So we got one, and then the other one won't. Yeah, so as you can see with that, the ping pong balls wouldn't stay on there both at a time just because the air wasn't strong enough. But it was worth a try to see what would happen. But yeah, that's the hairdryer experiment. Yeah. Okay, so what we're going to be doing right now is making a cornstarch solution that's actually considered what's called a non-Newtonian fluid. And what that means is it doesn't obey like the Newtonian like laws when it comes to the fluid. And the reason for that is it doesn't act like a normal fluid. And you'll see what I'm talking about during the experiment. But what actually happens with this liquid is it acts more like quicksand almost, is a very good example of a non-Newtonian fluid. Because when you hit it really hard or squeeze it, it will actually freeze in place and act almost as a solid, which obviously isn't the case with just like water, for example. But it is the case of cornstarch and water. And so when you will and I'll show this during the experiment, when you close your hand around it, it will freeze and act as a solid. But then as soon as you let go, then it will turn into a liquid. Okay, so to get started, what we're gonna do is put the cornstarch in, and then add some food coloring, make it interesting. And we're gonna add the water. Now don't add too much water, that's very important. For some reason the food coloring is blue, which is interesting, because it looks green. But so we're just gonna stir it. Okay, smells very bad. What's interesting, because as you can see, let me grab this, it looks like a liquid, right? But, I'm just gonna put it back. What we're gonna do now is grab it like this, squeeze it, and it actually feels solid in my hand, but then when you stop squeezing it, it's gonna melt. See, I'm gonna squeeze it, and then it's gonna start melting. It's hard to see. Okay, I'm gonna try to get it closer. So, I'm grabbing some. It's very sticky. I got it, and it's all liquidy. See, I'm gonna squeeze it, Now it's a solid. You can see it for a second as a solid. And then it starts to turn into a liquid almost immediately. So there's that one. Now what I'm gonna do is I'm gonna slowly put my fingers down into it and try to pull it out. I'm just gonna tell you what happens. It becomes really hard. It's really sticky. So like obviously I can pull it out, but it took me a second. Like I'm gonna try to pull it out really fast right now. And then it takes a second, see? It sticks. So yeah, so that's another aspect of it. And that's kind of this quicksand aspect I was talking about earlier. Is if you stop moving it, it's actually kind of like water, and that's what people tell you to do in quicksands. When you start pulling, it becomes harder and you get stuck. So there's that one. And then what I'm gonna try to do is form it into a ball now. I'll try to grab some. Feels almost like Play-Doh at the bottom. I'm gonna make a ball, which is very hard to do. I'm gonna show it to you for a sec, and it's already gone. See? So it's really hard to make anything stick like this, but it does form a ball for a second and feels like a ball in my hands until I stop putting pressure on it. Now the final one, and my hands are quite dirty at this point, is I'm gonna grab this spoon and I'm gonna place it on top. And it actually sinks slowly. Now if it's mainly water, it will actually stay on the top, but it's actually sinking just a little bit. I'll try it again. It doesn't go all the way down, but it sinks a little bit, which is interesting. It can't go much farther, but I think if the bowl was bigger, it would sink all the way down. And I would show you, but I can't get the camera destroyed like this. But that's what it, well, I can try to show you the bowl. Actually, I don't think that's gonna work, but yeah, so that is the Newtonian fluid experiment and how Newtonian fluid or non-Newtonian fluid works. Okay, so this is the density 2 lab. And first to explain like density just in a little bit more depth. Density is the measure of how much mass there is in a given volume. So basically it's a ratio of mass to volume. And there's a formula for this, which is D equals M divided by V, which is a pretty simple equation, honestly. In the world of chemistry, they get vastly more complicated than that. Basically, if the mass of something increases but the volume stays the same, so something becomes heavier but there's the same amount of space in that structure. So if I add a liquid to this jar, but the liquid becomes heavier, and that's going to be demonstrated in this lab. But if I add a mixture that's heavier than water, and there's already water in this jar, then that mixture is going to go to the bottom. So therefore, the density would increase. But if the mass decreases, but the volume, again, stays the same, then the density will also decrease. So really, it's kind of dependent on the mass for the most part. It also does depend on the volume, because if the volume does get larger or smaller, it affects the density as well. So all different kinds of liquids have different kinds of densities. That's why we have water here, honey, dish soap, and I have olive oil right here. But all of these liquids have different densities. So we're just going to be showing that today in this experiment. And I'm going to start by adding 1 drop of red food coloring and 1 drop of blue food coloring to 1/4 cup of honey. So we've got 1/4 cup of honey right here. We're gonna stir it, so that's why we have the jars to stir this stuff up. It might take a minute to get all this out. We're gonna have honey a little bit. Okay, that's almost 1/4 of a cup. We're almost there. We ran out a little bit of honey. But it's about there. So we're gonna add red and blue food coloring. Just 1 drop of red. So there we go. We're just gonna mix it up a little bit, just right in there. It's gonna turn purple, which is an interesting color for honey. Awesome. So as you see, we got our purple liquid right there. It's a little golden. I'm gonna stir it a little bit more just to make sure it's nice and purple. All right, awesome. Okay, so we're gonna pour that into this jar, and this is a pretty big jar. I unfortunately didn't have a smaller jar. Actually, the move might just be to put it into one of these jars. I'm gonna do that. I don't think the jar needs to be. Okay, so we got the honey in there. And now what we're gonna do is next add 1/4 cup of blue dish soap. Okay, so we're gonna add 1/4 cup of this. We have to pour this very slowly. We don't want it mixing. This smells a lot better than the honey. Slow and steady. Alrighty. I can already see the differences. Okay, now we're gonna add a few drops of green food coloring to the 1/4 cup of water and mix it combined. Okay. We're gonna use a different measuring tool and estimate a little bit. This is just a little bit more than 1/4. We're not gonna fill it quite all the way up. There we go. Hopefully this is the right color. It says it's supposed to be green, but it looks a little bit blue right now. Interesting. Okay. We might have to make it yellow. For some reason it's blue. Despite the fact that it says it's supposed to be green. I have more food coloring. Oh wait, there we go. Now it's a little bit more. There we go, now it's green. Okay, so we're gonna add So we're going to pour it very slowly again. Just a little harder with water. Alrighty. You can start to see, if I put it right there, the different layers. Okay, so now we're going to wait a minute and then we're going to pour 1/4 cup of olive oil into the jar. So we're going to grab this. Whoops. It's yellow. Just gonna wait a minute. It's very cool how it's already different colors, the different layers. I don't think I got the measurements exactly right though. Okay, we're gonna pour it in very slowly. Oh wow, that looks very cool. Alrighty. So now, it's mixing a little bit, but you can see the red at the bottom, or purple at the bottom, blue, green, and yellow. Awesome. So now we just have the last thing. The red alcohol. Here's the last thing. we go. That's there. Mix this around a little bit. Now I'm gonna add a red alcohol. Awesome. Okay. So I'm gonna let it settle for a minute. It's a little hard to see. But so it's not 100% right now. It might take a minute to settle in. But as you can see, there's very specific, pretty easy to see layers. I'm gonna try to turn this. The yellow's a little bit better right here. So you got the red on top, then the yellow, so alcohol, olive oil, then the water, the green water, the blue dish soap, and the purple, purple honey. And so that's just showing how each liquid, first of all, has a very different density in and of itself. And it's interesting to think because since the mass and the volume equals the density, the mass of each liquid, or the overall density, is different, but if you were to increase the volume of this cup, the overall mass, the overall density of this entire thing would be different. So that's a very interesting fact, just in and of itself, is that if you change what it's held in, or change how much of each liquid there is, which would change the mass, it would overall change the density. So yeah, that's the Density Lab 2 Rainbow in a Jar. Yeah, I hope you enjoyed it. Okay, so this is Density Lab 2, or no, this is Density Lab 1, I'm sorry. And I actually did them in opposite order, just for ease. But so what this one's going to be kind of like showing is how the density of water versus just oil, which I kind of showed in the previous one. But what's going to be cool about this one is it's going to be showing really how water, when the molecules in a liquid are closer together, they're therefore denser and heavier. So that's why like honey sinks to the bottom in the last one, and water was more on top, where alcohol was on the very top. Now what's going to be happening is when I put the Alka-Seltzer tabs, which I have right here, into the mixture while doing the experiment, what's going to happen is bubbles are going to bubble and go through the oil almost and come to the top, which you'll see in a minute. But I'm just going to be, and this is supposed to look like a lava lamp, which is very cool. So I'm going to fill this jar up about 2/3 of the way with oil. So that's about good. Alrighty. And then fill your jar, and I'm going to fill it the rest of the way up with water. And actually, I feel as though I might have put a little bit too much oil, so I'm going to take that back real quick. Alrighty. That's better. I like that amount more. Okay. And then the rest is going to be water. Awesome. I already see a lot of bubbles in there. Now, I'm going to add a few drops of food coloring. So I just need to grab that real quick. You can already see them separating out here. And so I'm going to add the food coloring. Just a few more. Alright, cool. Now I'm going to drop in an Alka-Seltzer tab. That's what I got here. Let's see, how do I open this? So I'm going to add the first one in. And it went all the way down and hit the water, and now it's going to start bubbling. You see the bubbles are going to the top. They're going right through the oil and coming to the top. And then I'm going to add another one once the reaction slows down. You can see at the bottom it's getting very fizzy. It looks a lot like a lava lamp, like I said.
Yeah, so you can see how the carbon dioxide is rising to the top through the oil, and then bubbling fully at the top. And honestly, it looks horrible. I would hate to drink this or something along those lines, but it's very interesting. Another one. This is what soda is, basically, so that's a little terrifying. But yeah, so that is the experiment, and there's actually a lot of different colors going on right now. There's some blue at the top that is kind of hard to see. I'm gonna try to show you guys. There's some blue at the top, right there on the bubbles. And then you can see the yellow and the red at the bottom, which I'm not 100% sure why the red's there. But yeah, so that is the experiment. Yeah, I hope you guys enjoyed. This is how to make your at-home lava lamp. You can see it looks a lot like a lava lamp. But yeah, have a great day.
Okay, so the lab that is happening today is the viscosity lab. And viscosity, just to give some background on like what viscosity is it's a liquid's resistance to flow. So you see things like water, vegetable oil, syrup, and honey, which are the 4 that I'm going to be using today in this experiment, all have different viscosities, and that's going to be shown by this marble, which I'm going to be timing going through the liquid. In this case, I have honey right here, which is hard to get in there because it's so viscous. It has such a high viscosity, it doesn't flow very well. If I go like this, it's going to stay in the same spot for a while and then start flowing a little bit, but it doesn't really flow that much. And unfortunately, I don't have a lot of honey, so I have to use this cup, but we're going to be timing how long it takes for the marble to fall through the liquid, and that's going to kind of represent the viscosity a little bit. But how I'm going to be doing it is I'm going to show one trial run with the marble for each liquid. I'm going to be doing it 3 times. I'm only going to show it once for each, just to save some time. It's going to take some time to clean up the cup in between because I have to use the same cup, same amount of liquid. But yeah, so we're going to be starting with the honey, and just for reference, I'm going to be measuring from the top of this blue strip to the bottom of this blue strip. I'm going to try to be as consistent as possible. I didn't really have anything better to mark it with since it's glass. But I'm just going to start the first one as soon as I drop it. Okay, it's taking longer than I expected. You can kind of see the marble. It's really taking, it's like in slow motion. It hasn't hit the bottom yet. I'm gonna turn it around real quick. And it got it. I don't know. It's a little hard to tell, but that was the first time. Yep, so that was the first trial run for honey. I'm gonna show just one of each of the other ones. So next up is syrup, and just to draw attention to how they pour, like viscosity wise, it took a really long time to get the honey to fill this, like up to that blue line. Syrup took like 3 seconds, gonna be even faster for water, potentially even faster for vegetable oil. Yeah, we're gonna start with the syrup now. And one thing I just wanted to draw attention to, like a potential error in the experiment, it was really, really hard to tell when the marble was hitting the 3 times with the honey, like actually hitting the bottom. So I had really high times. I feel as though that might not be super accurate to how long it actually takes for the marble to hit the ground in the honey. Yeah, that's one potential error. It was like refracting a lot. It was really, really hard to tell. Hopefully it'll be easier with the syrup. So this is the first trial run, it's the syrup. As soon as I drop it. Yeah, that was like 2.6 seconds. I think it went a lot faster than the honey, I'm gonna be honest with you. Yeah, so we're gonna do that 3 times. Okay, now we are doing the vegetable oil, and just to draw attention to human error in this experiment, it's hard for me to time exactly like when it hits the liquid and when I start the timer. I try my best, but that's just another human error. I noticed last time when I did the syrup, the first time I got 2.60 seconds, and the second time I got less than 2 seconds. So I'm sure there's some human error there for sure, because you'd think it would be a little bit more consistent than that.
And the same with the honey. Like, honestly, I couldn't even see when it hit the bottom. So we're gonna start the oil now. 3, 2, 1, go. What the? Okay. I'm not even, that wasn't even worth, it hit the ground immediately. That was kind of weird. It was almost as if it didn't even go through liquid. I couldn't even get, that was like 0.1 seconds. I couldn't even time that on the timer correctly. I'm gonna have to do that again. I'm gonna write down what I got here for the first one, but that was definitely some human error. There's no way I can even press the stopwatch that fast. Okay, and the last experiment, water. And just to say about the vegetable oil, there's definitely some human error. Basically, to describe it the best I can, as soon as I put it in, it was gone. So, like, it was done. It hit the bottom. So I'm just gonna do water, and I need to pour a little bit out. I misdid that, or I mispoured it a little bit. There we go. That's better. Now it's about even right at the top. It's a little crooked. It's just a little crooked now. But it's at the top of where it used to be. Okay. 3, 2, 1. That was even faster. It literally balanced. Okay. We're gonna go with that. 1.19. Okay. So yeah, that was water. And I'll show you guys my findings from the 3 trials in just a second. And honestly, out of all the experiments I've done throughout this course, I've never had one where there was so much human error that could happen. It's probably because I didn't have a lot of the liquid, like I didn't have a ton of honey and stuff, so my amount was not very large. It's probably about like that high. So that probably played into it a little bit. If I had a little bit more honey and a little bit more syrup, I probably would have been okay. It would have been better. But so the order of the viscosity, like honey was definitely the most viscous, then syrup, and then actually I think vegetable oil, and then water, because I don't know how much this plays a factor. This is just a hypothesis of why this happened. But the vegetable oil, it sank, but it sank somewhat controllably. In the water, it actually went straight down and then bounced. And the times somewhat reflected that. This one is definitely an error. So I guess really maybe the water was more viscous because it did take us just a little bit longer. It was just interesting how it bounced to me versus in the vegetable oil where it hit the bottom and just stayed there. I don't know if that's a sign of viscosity, but that's just maybe what happened in those given liquids. But these are the more accurate times of the vegetable oil. And the water was all around about 0.2 seconds, and the vegetable oil was a little above 0.1 second. So that's very interesting. And then, as I said with the honey, definitely some human error there. It's not that long. It's probably more like, I would say like 5 to 10 seconds. But I didn't want to be fake, so I tried to see when it hit the bottom in my mind. And that's when it seemed to hit the bottom consistently for me, but it was very, very hard to tell. It probably, again, would have been easier with more honey. But yeah, so that's the experiment. I hope you enjoyed. Definitely a lot of human error, but did our best here. So yeah, thank you.